The history of planet Mars contains secrets about our own origins and possibly our future. Although we know an awful lot about the planet's life, getting a human to touch down will be another big leap for mankind. That's because despite it being our closest celestial neighbor, the red planet is 140 million miles away. Getting there would take 9 months, but for a round trip, you'd have to wait on the rocky surface for a quarter of an Earth year until the orbits lined up well enough to make your voyage home easier. But at least that would give you enough time to examine how the barren landscape once gave way to running water. That's right, the red planet used to be blue. When Earth was cooling from its fiery form, Mars had oceans. Oceans that were possibly larger than any on Earth today. In fact, NASA has confirmed Mars is not quite the desert we think it is today. Researchers detected evidence of hydrated minerals in streak patterns on slopes. Over time, these darkish streaks appear to shift in appearance, as if flowing over time. It's hardly a lush waterfall, but this discovery has already upended long-held beliefs of the planet. Yet, this is a drop in the ocean of what Mars used to look like. Judging from river valleys and mineral deposits, the ancient oceans could have been as deep and wide as its entire northern hemisphere. With such vast waterscapes, scientists speculate these lost seas may have offered a cradle of life, but whether that life was intelligent remains an open question. The current consensus is that any life on Mars is, or would have been, microbial, meaning not the alien life forms we were all hoping for. Hopefully, this is just the beginning of our search for extraterrestrial life. Most likely, organisms like this would have inhabited the shorelines or thrived deep underwater. They might not have been like the strange creatures lurking at the deepest depths of our planet's water bodies, but we won't know for sure until more of the planet is scouted. Thankfully, Curiosity has been exploring the uncharted territory on our behalf. The car-sized rover was originally sent on a 2-year mission to investigate the planet's climate and geology. But its mission has been extended indefinitely, in part due to its discovery of organic molecules. It even noted seasonal variations of methane. Now the question is whether these materials were mere geological processes or signs of our earliest ancestors. The answer to that depends on when Mars became inhospitable. 4 billion years ago, Mars lost its magnetic field. This would have left Mars vulnerable to drastic shifts in the environment, as well as exposing it to harsh solar wind. Bit by bit, the atmosphere would have been stripped, thereby losing surface water. Oceans would have frozen once Mars's atmosphere thinned, and this would have been sped by the volcanoes stopped being active. There's also the chance that the planet's smaller size, just over 50% smaller, would mean its gravity was too weak to hold on to any atmosphere for long. As temperatures dropped and deserts formed, any potential life would have encountered challenges so extreme that the chance of survival was less than zero. Oceans drying up led to the iconic geography we have now: vast deserts, towering volcanoes, and cracked, rocky terrain. It goes to show what could lie ahead for us if our atmosphere suffers the same failures. Mars's demise and squandered potential is a stark reminder of how our fragile existence is dependent on a carefully balanced ecosystem. As for whether we'll be able to avoid the same fate, that all depends on what more data can be gathered from the red planet. As limited as Curiosity's range is, it's already provided valuable insights. Hopefully, us humans will be able to explore the planet's history for ourselves. It appears our survival depends on it.